Hello, this is Rick Powers coming to you from my home office for introductory statistics. And we're looking at finding a confidence interval for the mean using SALT. And so I'm going to share my screen with you so that you can see what I'm doing. All right, so I'm going to go back to a situation that I'd shown in another video where I have a data set and I do a sample. And in this sample, I only have 6 in my sample. And so what I get here is from this one sample, the mean is 42.3, pardon me, and the standard deviation is 7.1. And I want to say, how wide of an interval do I need in order to make sure that I've captured the population mean? So when I do this, I go out to SALT. But first of all, what I want to do is I want to take a look at the formula here. The formula for the confidence interval for the mean, of course, I have the sample mean is my estimate, but I know that's not going to be correct. So I need an interval to say, where do I think the population mean actually is located? And this is where I need a t critical value. I need the standard deviation, and I need the square root of n. Now, this should look familiar, standard deviation divided by square root of n, but it's not the population standard deviation. It's the sample standard deviation. Because when I get a sample, that's all I know. All I know is what the sample gives me. And mathematically, in this situation, because I don't know the population standard deviation, then I have to use a t critical value. So, first of all, going to SALT here, we're going to look at our distribution calculators. And previously, we had talked about using the z-score here. But now we're going to have to use the t distribution. And the t distribution has something called degrees of freedom. And I'm going to put that out here so that you can know that, if I put a text box down here, that the degrees of freedom is equal to n minus 1. So when I need to find a critical value of t, I need to know this number, n minus 1. So in this case, my degrees of freedom are going to be just 5, because my sample size is so small, then my distribution becomes really wide, okay? So there's a lot of uncertainty here. And notice when I have a 95% confidence interval, it's between negative 257 and positive 257. So it's way out there. So that would be the number that I would put in here, my t critical value. Again, I'm doing between here. I'm not using a left tail or a right tail, but I'm doing between, and I put my probability down here to say this is what I want between. If it's a 90%, well, then I change it. Notice it becomes smaller. My probability is smaller, so my interval is smaller. So then these are the numbers that I'm going to be using. Well, again, when I say I would put that into this formula, I don't have to do that with SALT. SALT is able to figure this out on its own. So I'm going to go back here and I'm going to look at my sample. Notice all I know is one sample. So the mean is 42.3. I'm going to go to inferential statistics, one sample t. And I'm going to get rid of this. I'm going to say my sample mean is 42.3. My sample standard deviation is 7.1. and my sample size is 6. And I'm going to do a 95% confidence interval. Okay, so here's 42.3, standard deviation 7.1, degrees of freedom 5. So that's 34.8 to 49.8. Well, if I go back here, 34.8 to 49.8, that's going to be that wide across. And that does include the mean that I wanted. My population mean was 43. So this worked. My interval is wide enough that it's going to include the information that I need. Well, what if I do a different sample? So I do a different sample of 6 people. Well, it came out to be pretty close here to be the same. What if I do another sample? Will it also be the same? It's also pretty close. Well, let's keep going. See if I can find one that's not quite as close. All right. So this has a mean of 39 and a standard deviation of 8.2. So my mean is 39. Standard deviation is 8.2. Again, confidence interval. So now my confidence interval is different. It's from 30.4 to 47.6. So every time I do a sample, I'm going to get a different confidence interval. And I'm just hoping, but not just hoping, I'm confident. I'm 95% confident that the population mean is actually inside this confidence interval. But again, it depends on the standard deviation. It also depends on the sample size. If I have a large sample size, then my interval can be smaller. Then I can be confident, but also have a smaller interval. So that's good. All right, so once again, when we're talking about doing confidence interval for the mean, we put the sample mean here, and the sample standard deviation here, and the sample size. All 3 of those things are necessary in order to be able to make this work. And then we put in our confidence interval here, and then that will get us an interval that most of the time, in this case, 95% of the time, it will give us an interval that contains the population number that we're looking for. All right, I hope that's enough information for you. And please let me know if you have any questions about confidence intervals for the mean.